We are going to look at dividing complex numbers in this example. We're going to bring in kind of some thoughts that we've seen before in other problems. So here we have 5 minus I divided by 2 plus 3I. So if you remember when we were dealing with i's when we first learned them, we know that we cannot have an I in the denominator of our fraction. So we are going to multiply this by its conjugate. Anytime you have two terms and there's a radical or an I down here, we bring in the conjugate to help get rid of that. So I'm going to say 2 minus 3I, but then I have to multiply the top by that as well, so I'm going to throw parentheses around this and say 2 minus 3I. Alright, the denominator is the one that's going to be a shortcut because we're multiplying two conjugates. So remember, you can do the first terms, 4, and then 3I times a negative 3I is negative 9I squared. But this I squared is negative 1 times, so now I'm going to do negative 1 times negative 9, so I have 4 plus 9, which is 13. So I have 13 in the bottom of my fraction. Alright, in the numerator, we're going to have to FOIL this out. These are not conjugates because they're not the same complex number 1 plus 1 minus. So, this work I will do over here. So we FOIL this out. 5 times 2 is 10. 5 times a negative 3I is negative 15I. Negative I times 2 is a negative 2I. Negative I times negative 3I is a positive 3I squared. Alright, we have this I squared, which is negative 1 times 3, so I actually have a negative 3 down here. I'm going to combine the negative 3 with the 10, so 10 minus 3 is 7. And then I'm going to combine these like terms. Negative 15I minus 2I is negative 17I. So that is my numerator, 7 minus 17I, all over 13. Alright, this next example is going to be very similar. We are dividing by 6 plus 2I, so we're going to multiply it by its conjugate, 6 minus 2I, and we have to multiply the top by 6 minus 2I also. So we get to do the shortcut with the 6 plus 2I and 6 minus 2I. We just multiply the first terms, 36, and the last terms, negative 4I squared. Remember, this I squared becomes a negative 1. Negative 1 times negative 4 is positive 4. So we actually have 36 plus 4. Our denominator is going to have 40. Alright, now we have to FOIL out the numerator. So all of this, I'll put the work over here. 2 times 6 is 12. 2 times negative 2I is negative 4I. I times 6 is a positive 6I. And I times a negative 2I is a negative 2I squared. Alright, this I squared is negative 1 times that negative 2 is a positive 2. I'll combine 2 with 12 and get 14. And then negative 4I plus 6I is a positive 2I. Alright, so let's talk about if we can do any simplifying with this. We haven't had an example yet where we could, but now I see 14 plus 2I divided by 40. The 14, the 2, and the 40 can all be divided by 2. So if you want to look at your three numbers, if your answer looks like this, and if you can divide all of them by the same number, then you can reduce this. 14 divided by 2 is 7, 2 divided by 2 is 1, leaving us with just the I, and 40 divided by 2 is 20. So we can reduce our answer as long as every number can be divided by the same thing. Alright, last one for this video at least. We got a complex number in the denominator, multiply it by its conjugate, 3 plus I, multiply the top by the same thing. We can do our shortcut with the conjugates. 3 times 3 is 9. Negative I times I is negative I squared. Again, this I squared is a negative 1. So you have 9 minus a negative 1, which becomes 10. So I have 10 in our denominator. And then our numerator, it's just one term times our complex number, so we can just distribute here. So 2 times 3 is 6. 2 times I is 2I. So again, look to see if you can do any reducing. The 6, the 2, and the 10 can all be divided by 2. So 6 divided by 2 is 3, 2 divided by 2 is 1, so the I just comes down, and 10 divided by 2 is 5. And that's our final answer.